Hello, one and all, and welcome to our first installment of chemistry for the year. What we have for you today is going to show a couple examples of things that we're going to study as we go through the year. One thing to keep in mind, and something your teachers will reinforce as we go through, is to think about why these things are occurring. Okay, not just what you see or the observation that you can make, but we are going to get into why these things are occurring. Okay, so try to keep that in mind as we go through this. Once we see what happens, we will sort of discuss them. Okay, so first up, we have a couple of containers of water here, and just a regular old can of cola. Okay, the soda can is completely closed. Okay, not empty at all. All right, let's see what happens when I put it in to our tub there. Okay, let's take a look there. All right. And now I'll transfer to tub number 2. Aha, what do we see? Okay, can we notice that? What is happening there? Okay, the can on the right is floating. Okay, so take a couple seconds and think to yourselves, these are 2 just plain tubs of water. Nothing has been added to those tubs of water. Okay, an empty can of Coke, regular Coke. What is happening here? Take a couple seconds. Okay, and so what you're observing, and I'm sure your teachers will talk about, okay, one little hint, one little giveaway that we see here. If you look really close, okay, what do we see on this side of the container? Okay, well, that is condensation. And when can you see condensation? When do you see your soda cup, your big gulp sweat? Okay, well, that's usually when you have something cold in it. Okay, so what's happening here is the container with the hot water has particles that are moving faster, thus it has a higher density. Okay, and the can of cola is going to sink. Okay, in the cold container, the water particles are moving more slowly, thus you have a lower density, and your can float. Okay, so this combines actually a couple things that we'll talk about. We're going to talk about density in our first unit. We're going to talk about particle motion and that kind of thing in our first semester as well. Okay, so just some things to keep in mind. Okay, for example number 2, okay, we have just a run-of-the-mill film canister. Okay, you all may not even know what these things are. Okay, maybe you haven't seen one before, but way back in the day before cell phones and digital cameras, right, you had film that came in canisters looking like this. If you take Mr. Fran's photography class, you definitely will see one of these. Okay, but this is what they call a film canister. And into this canister, I am going to pour a little bit of liquid. Okay. Right, and to the top of the canister, I'm going to add just a little bit of powder. Not sure if you can see that real well. Okay, which is basic baking powder. Okay, and we're going to see what happens when I combine this. So, what was it that we saw? Okay, perhaps you've seen something like this before. Think for a second, why did this happen? What went on inside that canister? and what caused it to pop off. So perhaps, as you know, okay, when you mix vinegar and baking powder together, you get sort of an instant reaction. Okay, so we had a chemical reaction recur inside that film canister, and among other products, what it produced was gas. Okay, so that's an example of a chemical reaction. That reaction produces a substantial amount of gas, and when we had this canister sealed, right, I completely closed it off, okay, like so. Well, the gas builds and builds and builds until this can't hold it anymore, and our top flew off. Okay, this is what we would call an example of gas laws. Okay, there is what we call an inverse relationship, or a opposite relationship of pressure and volume. So as the pressure of the gas built up inside this canister, the amount of volume it could hold decreases, and that causes the top to fly off. Okay. Alrighty, we have come to our third and final installment here of our intro chemistry demonstrations. Okay, I have here for you two different balloons. These are your, regular run-of-the-mill dollar store latex balloons. Okay, not much different in them, except for one key thing. Okay, so I will take Mr. Red Balloon. Okay, and I have here a lighter. Okay, this is something you've probably seen maybe mom or dad use on Start Your Barbecue, something like that. Okay, and we're going to see what happens, and you can probably guess what's going to happen here to the balloon if I apply the flame to it. Are you ready? So, as you might expect, putting a flame to a air-filled balloon, is going to pop it, right? Doesn't seem that surprising. However, I have here balloon number 2. Okay, and now let us see what happens when I apply the flame to this one. 5, 6, 7, 8, 9, 10. That flame's right on there. Why is the balloon not popping? What is different between the green balloon and the red? I will give you a second here to think about it. Okay. All right, so I'm guessing you guys came up with some ideas. First off, the red balloon, okay, the regular old balloon, as you see, just has air inside of it. Okay, there's nothing other than the latex and air inside. And when you put a flame to it, whammo, the balloon goes away. The green one, however, had one slight difference, and I'm not sure if you can see as I get the balloon closer, but can you see what's sloshing around in there? Okay, that is water. Okay, and water has some very special properties, which we will get to as the year goes on. One of those properties is having a high specific heat. Okay, and what that means is that water can withstand a lot of heat before it gets hot. Perhaps you've seen, maybe mom or dad at home boil a pot of water for pasta or rice or mac and cheese or something like that. Well, it takes a little bit to heat up, whereas the metal heats up really fast. Okay, so the water inside of this balloon is protecting the balloon and preventing it from popping. Okay, just a very simple example of something that we'll get into in this first semester here. Okay, I hope you all enjoyed these introductory demonstrations, and don't worry, there will be many more to come. See you soon.